Okay, here in this video, we're going to talk about finding the volume, but this time we're going to talk about finding the volume of pyramids and cones. Now that's different than a prism because a pyramid and a cone has a flat side, a flat base. Now remember, they don't always put it on the bottom. Sometimes they rotate that and we have to find it, but it has a flat side and then the opposite, comes up and creates a vertex or a point, so to speak. So it comes into one place. So when I look here, I notice that I have a square on one side, on the base, on the bottom, and then all my sides pull together to create this one vertex at the top. That's a pyramid. This is actually, the base is square, so okay, let's just go and write that out like we did before. Let's say, well, that's a square. And because it comes to a point, I know I have a pyramid. So like all good buildings, everything starts with a good foundation. Just like the pyramids in Egypt, they have to have a good foundation in order for the pyramid to stack and go forward and go up. And so we're going to talk about this formula here. The formula for the volume of a pyramid and a cone looks so much like a prism. So here, I'm going to write out, this was our prism formula, right? Volume equals the area of our base. Don't forget, I'm going to write that out here. Area of our base. That big B means something. And then a small h here just tells me how tall, wants to know the height of the pyramid itself. But because we've taken the sides and folded them in, it can't be the whole prism, right? So here is where you find this part here, where it says it's only a third of it. So we take the exact same formula we use for prisms, and we just divide that number by 3. So let's set this up. Square and pyramid. We're going to go ahead. I know it's a square, but I'm going to go ahead and shade in my base. So that way I'm keeping an eye on the base because it's all about where does this start and how do we build from it. So here's my base. I'm going to go ahead. A square area is area equals side squared, right? So area equals, my sides are 12, so 12 squared. So the area here is 144. I'm going to go ahead and label that out so I remember this is feet and this is 2 dimensions right now, right? I'm talking about the flat square on the bottom. So that's 2-dimensional, so it's squared. Squares are 2D. Pyramids, though, are no longer 2D, right? Pyramids are now 3D. So we're going to talk about the volume. So the volume equals 1/3. Now I'm going to go ahead and remind myself that that is a big B is my blue. 1/3 base times height. Then I just plug in my information. So volume equals 1/3, or I could divide that by 3. The area of my base, we got to go back over here and grab that number, times 144 times h. Well, the height of my pyramid is right here. Tells me how tall the pyramid is. Right here, and it even gives you this. This tells me it's a right angle. That's important. It needs to be from the center down to the middle of the base is 10. All right. 1/3 times 144 times 10. 144 times 10, 1,440. Divide that by 3. Yep. Calculated that, you would come up with 480. This is still in feet, and again, this is 3-dimensional, so my feet are cubed. Here, we have a different base. If you notice, here's my base down here. And if you look closely, what type of base is that? Yep, that's a triangle, right? So, okay, so I have a triangular, and I look again, and I notice that it comes to a point, or has a vertex up here, so this is a pyramid. So I'm going to begin with my base. How do I find the area of that triangle? Well, the area of that triangle is area equals 1/2. Lowercase b, remember area, that's a lowercase b. The big B stands for the whole thing. Half of the base times the height, so area equals 1/2. Oh, wait a second. I need a base and height of a triangle. So when I look for the area of this triangle, and I'm looking, I need the 2 sides. I need the base and the height. The base and the height will always come together, base and height, create a 90-degree angle. So when I look here at my bottom, I notice that here's my 90 over here in the corner. So that means that my base and my height are the 6 and the 8, not the 10, the 6 and the 8. I want the two that come together to create a 90. So times 6 times 8. So half of 6 times 8, well 6 times 8 is 48, and I want half of that. So that would be 24. Going to go ahead and label. We're working with the measurement of inches. This is a 2D feature. It's at the bottom, it's flat, so squared. I've found the area of the triangle. So I know the 2D, but I want to extend this and turn it into 3D. This is what the height does. The height pulls it up and gives it this third dimension, meeting it in the middle at a 90 degree. So here's my 11. Okay, so volume equals, let's get the formula, 1/3, don't forget big B. So I want that capitalized, lowercase h. So the volume equals 1/3 of 24 times, how tall is it? Yep, 11. So how I would type that up is I would actually say, well, I want 24 times 11. And when I type in 24 times 11, now I want 1/3 of that. So I'm going to divide that by 3. So 24 times 11 divided by 3 is, 88. So 88 inches. Now inches 3D, right? We now I added height, so it's inches cubed. In my next example, take a look here. It's also a triangle on the base, right? Right here. So I'm going to go ahead and I'm going to shade this little triangle in. This is my triangle down here. And I know it's a pyramid because on the opposite side of this triangle is where I have all of the sides folding in together to create one place or one point. So I'm going to go ahead and label this. I know it's a triangle. So triangular. And I know it's a pyramid because it's coming straight up to one point, one vertex. I know I start by finding the area of a triangle. So area equals 1/2 of the base times the height. So area equals 1/2. Now I got to figure out what the base and the height are. Now, if I'm just looking at the triangle on the base, I don't care about how tall the pyramid is. I just want to focus on the triangle itself. Here is the 90 degree for that. So it's this side here, which is the 9.5. That's how tall it is. And then this side here is my base. So, okay, so times my base of 16 times the height of the triangle itself is 9.5. So area equals half of 16 times 9.5. And we get, calculate that up, 76 millimeters is my measurement. And this is 2D, so squared. Now we're going to make it a pyramid. Pyramids are volume. It's how much it fills it up. So volume equals 1/3 times the area of the base times how tall the pyramid actually is. So volume equals 1/3 of, well, we said that the big B over here was 76, so times 76, and then the total height. How tall is the pyramid is what this H stands for. How tall is the pyramid? Well, this is the measurement for that, and it is 14, so times 14. So how I would type this up, I'm going to say, well, I'm going to take 76 times 14, and then I want 1/3 of it, so I'm going to divide it by 3. And I have 354, then I have a decimal, and then after that I see that I have 6's repeating. Okay, my directions at the top said I needed to round to the nearest tenth. And this looks like a number I'm going to need to round. So my final volume here is going to be 354 decimal, because I want tenth, I want one place after. So I look, does this get to remain a 6 or do I need to bump it up? Does it need to move over here? 6 is greater than 4, so it's 5 or more, raise the score, so this becomes 7. And I'm going to go ahead and label it out, millimeters cubed. All right. So we've talked about squares or rectangles would work the same way. We talked about triangles and looking for the base and the height. That's really important. Where do the two sides come together to create a right angle? And now we're going to look at what happens when my base is a circle. So if you notice, we have circle, right? So circle is where we start. And then I get this 3D. So circles that are 3D are known as cones. We don't call them pyramids, we call them cones. But we know how to do this. We know how to find the area of a circle. Area of a circle is pi r squared. We're going to use 3.14 for pi, so 3.14 times my radius. My radius is right here, and this is perfect. Remember, radius is halfway, and that's exactly halfway, so 3.5 squared. We'll type that up, 3.14 times 3.5 squared. That gives us 38.465. Now don't round yet. Remember, when we're working with pi, or any of our squares, our cubes, any of the things that require us to work with decimals, we want to make sure we leave as much decimal as we can until the very, 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 very end. I am going to go and label this out though, miles squared, because I do know that this is a 2D object when I'm looking at the circle. And I did not shade it, so let's take just a quick second. I'm going to shade that circle in. But now it's time for the cone. Now we're going to add the third dimension. It's time to build it up. So volume equals, now we know that cones come in, they have a slant to them. So that's the 1/3 that we're accounting for. Capital B, lowercase h, and then we just set it up. Volume equals 1/3 of, well, the capital B stands for the area of the base. So times 38, I'm going to use all those numbers, 465. Times my height. Now the height is the height of the cone. How tall is the actual cone? And the actual cone is 16. Through the magic of calculation, I know that 1/3 of 38 times, or 38 and 465 thousandths times 16 is 205 decimal. 1, 4, and then I have these 6's repeating. We are rounding to the nearest tenth, so I only need one place after the decimal, so volume equals 205 decimal. I look at the 1, what comes after it? 4. Oh, so the 1 doesn't need to change. I just leave it a 1. And I label miles cubed. All right, that cone looks like it makes sense. The base is on the bottom. But what do you notice about the next cone? Yeah, they turned it around on us. They rotated it, which they do all the time, which is fine. It's still a circle, and it's still a cone. Now we can just put ice cream in it, right? So it's still a circle. It's still a cone. We're using the exact same formula. I'm going to start with my circle, my 2D, and then I'm going to move to my 3D and my cone. So my circle is area equals, oh, wrong color. We're going blue. Area equals pi r squared. So my pi, we're using 3.14. Now I need the r. So what is the r? Ooh, they did not give me the r. Look, they gave me the whole thing. That's the diameter. This is the diameter. This is not going to work. I need the radius, and the radius only goes halfway. So if the whole thing is 18 all the way across, and I want half of that, the radius over here is actually 9. Okay, so let's use 9 instead. So times 9 squared. The power of calculations, 3.14 times 9 squared, 254 and 34 hundredths. Keep all the numbers for now. That is feet, and this is squared because we are working two-dimensional. Now we're going 3D. So now we're adding the height, or how tall the cone is, and that becomes volume. So volume equals 1/3. We are going to use a capital B because we need the area of the base, not just the base. We need the whole area, times h, how tall it is. So volume equals 1/3 of, I'm going to go ahead and go back. This capital B is this number here. So 254.34. times how tall? Well, how tall is my cone? My cone is right here, it's 27, right? From the base, from the center of the base, all the way to the tippy top, 27. Use the power of calculations. I want a third of whatever 254 and 3400 times 27 is. And I find that that is 22, so 2,289 and 6/100ths. 0.6, that's 6/100th. And it ends, but that's not what they asked me for. They asked me to round it to the nearest tenth. So I'm going to go ahead and do that. 2289 decimal. Nearest tenth means I need one place. This has 2. So before I write that 0, I need to determine the number behind it. Does it force it to move up or does it stay the same? Well, 6 is 5 or more, so it's going to force it up. So this becomes 1. So 2,289 feet. Again, we're in volume, so we are in 3 dimension. 3 dimension means that my label is feet cubed. So it works a lot like we did with prisms, except here, because the sides have been pushed in, folded in, we need to account for the space that we're taking out, and that's why we have to multiply that by that 1/3. So here we go. Volume equals 1/3 of the area of the base. We got to find the 2D first. What is that area? And then we're going to multiply that by how tall it is and divide that out by 3.